Hello everyone, today we are here to learn about 8051 microcontroller. Before we start about the subject, let's have a small discussion what is the difference between a microprocessor and microcontroller. So microprocessor is the one where you have your CPU built on the IC like most of your processor, whereas the microcontroller is the one where you have built-in RAM, ROM and other peripherals along with the CPU or processor. That is the first difference we can say about processor and controller. The second difference we say that a processor is the one where it is an application where the task is not predefined and it is assigned by the user. For example, computer, mobile, video game, or for example, you can say laptop is the best example to understand. So everyone today we are using the laptop and the purposes are different, right? You can use it for simulation to get the output of a particular program. You can use it for a media streaming, you can use it for editing an image, you can go for web browsing, and all these tasks are assigned by the user, whereas microcontroller is designed for a specific task, and once your program is embedded on the microcontroller chip, it is really difficult to alter and you may need special tools to reburn it. So the microcontroller is the one where it is designed for a particular task or a specific task, whereas microprocessor is the one where your task is not predefined, it will be assigned by the user. Let's have a small block diagram difference showing the difference between the processor and the controller. So here you can see in the processor you have arithmetic logic unit, we have all the general purpose registers, accumulators, program counter, stack pointer, clock circuit and interrupt circuits, whereas the microcontroller along with all these existing features what we have in microprocessor, that will also be there in controller, provided you will be having the internal ROM and RAM which is also built in. That is the first difference you can have between your microprocessor and microcontroller. Right, so that is what we have written here in the table, microprocessor and microcontroller. So coming with the respect to the instruction set, we'll say that we have many instructions in microprocessors for moving of the data between the memory and CPU, where if you want to move the data between memory and CPU, then we encounter very less number of instructions in microcontroller. So when we are giving data, when we are saying the input, it can range from bit, byte or word. It can range like bit, byte or word. So based on the size of the data, you call it as a bit, byte, word, double word, So here in microprocessor you have very less instructions so that you can handle 1 or 2 bit of information, whereas if it is with respect to bit handling, then you have many instructions given in microcontroller. Then if you want to access your program or data between the memory and IO devices, then the time you need is more in microprocessor, whereas it is less time you need in microcontroller because all you have is built in. So the microprocessor based system requires more hardware because all this RAM, ROM and external devices has to be externally connected, where all them have been built in your microcontroller, where you are reducing the hardware PCB size. So whereas MIPI based systems are more flexible in design point of view and they are less flexible, we say. So like this we have the many difference between the processor and controller. And one more difference we can say that we are using the single memory for both data and code with respect to processor, and we are using the different memory for data and code separately when it is respect to microcontroller. Right. So next we have a term called as embedded system. So embed is generally the meaning is you are constructing on or you are imprinting on, right? It is constructed permanently, something like that, right? So you can say that an embedded system is a combination of hardware and software which are fixed in capability or programmable, designed for a specific function or functions within a large system. You got me? So you can say that an embedded system is combination of hardware and software where your capability is fixed or you can even programmable, and it is designed maybe for a particular task or a single function or many functions, right? The different example you can use is automobiles, medical equipments, household appliances, industrial machines, vending machines, etc. So based on this, we have the next topic called as embedded microcontroller. Just now we said embedded system is nothing but the combination of hardware and software, where it can be fixed capability or programmable, where your function is single or many. So now what is this embedded microcontroller is, just think we have a task, and for to complete that task we have built a complete hardware, and that complete hardware has been built or has been embedded on your microcontroller chip. Then it is called as embedded microcontroller. You got me? When a complete hardware required to run a particular application is provided on the microcontroller chip, that system is called as embedded microcontroller. Therefore the whole hardware is available on the microcontroller chip. Therefore if you want to work with the system, you need only power, reset circuit and clock. If you have the power, reset circuit and clock, then definitely your embedded microcontroller is going to work, and this can communicate with the external devices with its digital I/O pin. So simple block diagram we have shown, the representation we have shown here. You have an embedded microcontroller where everything is built in on your, the whole hardware is put up on your chip, and you can get communicated with the external devices with your digital I/O pin like parallel I/O, serial I/O, interrupt control, timer and counter control. Done. So next topic we have is criteria for selecting microcontroller. For example, nowadays it is so happen that even for selecting a phone, right, we will be going with different criterions we do follow. It will start with the shop from where we have to take, and again we'll go with the company, which company we want. Then we'll go with the different features like memory, what is the memory we have, and next we'll say about the camera, right, camera resolution, what is the front camera resolution, what is the back camera resolution, where we want your picture to be perfect, beautiful and perfect. Like this, for buying a simple phone, when we are finding out this much criteria, then definitely it becomes really important or really crucial to find out or to select a microcontroller, right? So when we go for that criteria, the first criteria, it says that it should satisfy the computing needs of the task efficiently and cost effectively, right? Your work, the computation what you are going to give, it should be done efficiently, and of course cost should be very less. Next we say about the speed requirements. Yes, how speed we are getting the how speedily or how fast we are getting the response for the input we have given, what is the memory we are using, what are the number of pins we are using, everything it is, and the consumption of power should be very less, we may say, right? So this is the second criteria. And the next criteria we say the availability of software development tools such as compilers, assemblers and debuggers. Of course we want oftenly available so that we can upgrade the software, whenever we need a particular task we can make it easy to done. Next is how easily it is available, maybe now or in the future, right? The next thing. And next we have how easily you can upgrade to a higher performance. Of course we want, as the technology grows, as the technology is changing, we just want to upgrade ourselves so that we can have a higher performance and of course the lower power consumption. So based on this criteria, we can go for the microcontroller to be selected for a particular task to be done, and where your task should be completed efficiently and the cost should be very less, right? So we will, of course we will check on about memory, we'll check out the power consumption, right? Everything we have to be user friendly so that we can say that yes, this controller or this task is going to complete in a good way. Next comes applications, where and all we can find the applications of the microcontroller. And of course the first application goes about house appliances. Yes, of course washing machine, refrigerators, microwave ovens, etc. The next you can go for calculators. You have your calculator, keyboards, printers, modems, they are all microcontroller based. And then when you go for the little bit larger, then it is like industrial controllers. You can have data acquisition system, in communication system, there you can use. Then you can go for automobile engines, flight control, and there lastly you can use it for military applications. So everywhere we want a controller so that you can you can complete your task in a good way. And of course it is the one, a controller is the one where your task is already defined.